Oh, hi everyone. Hi everyone, we'll be going live in a few moments, starting at 2 o'clock. What do we need this time? I'll just quickly let you know what we've got, yeah. So for one of the experiments, this is the one where you're going to need 2 cups. We're not going to start just yet, everyone. Just about 3/4 full of water with a little bit of space on the top. That can be a little bit of prep work you can do. And you're going to need a few things. I've got a big bucket of water. But if you've just got a glass like that or a bowl, it will be okay. And what we're going to do is we're just going to test some things, whether they float or sink in them. So just a few random objects that can go in water, so nothing electrical, but are things that can fit in your either cup or your bowl. We're going to get started in 2 minutes. What was that? Well, hi everyone. We've got a couple more joining us. Just if you've just joined us there, honestly, if you want to do a little bit of prep work, because sometimes when we do science, we need to prepare things. If you just get 2 cups of water, plastic cups, and just 3/4 fill them full of water. And so we're going to be testing things if they float or sink. If you want to use a cup, that's fine. I'm going to use a big bucket. So all you need is just some 5 or 6, 7 or 8 random little objects that you think some will sink and some will float, and we're going to kind of explore why. So we're going to get started in 1 minute. So I'm just going to put these. Of course, there. How are we doing for time? What's 2 o'clock? Lovely. Oh, right. So we'll go sit the right way. Hi everyone. Right. So I'm just going to start talking for a few minutes, and if any people are a little bit late, it'll be okay. I'm just going to talk for a few minutes. If this is your first session, brilliant. Nice to meet you. I'm Neil. This is a Science with Neil. If you've tuned in before, brilliant as well. All I'm going to do is I'm going to quickly recap the last lesson, which was on forces, because forces are also going to kind of be important today. So today's session is floating and sinking. So as I said, forces are important. If you have just joined us, all you're going to need, if you want to do a little bit of prep work, you're going to need 2 plastic cups, about 3/4 full of water. That's going to be for the second experiment. And for the first experiment, you're going to need some kind of random objects. Now, I'm going to use a big bucket so you can see at home, or you can just use another plastic cup, about 3/4 full of water again. And what we're going to do is we're going to test little objects, random objects, to see if they float or sink and explore why. So I'm just going to put all this over there. Yeah, so a few more. So welcome back. So my name's Neil. I'm going to quickly recap last lesson, because last lesson we looked at forces and we kind of looked at friction. But we looked at force to see why things move or why they don't move. Now, I've sat on the creaky chair, sorry. So the creaking, it's not me, it's the chair. So I'm just going to quickly talk about this apple. Now, remember, this apple doesn't move because the forces acting on it are balanced. So there's gravity pulling the apple down, but the table is pushing up against the apple. Now, this also is similar when we talk about liquids. So if I put this apple into the liquid, you should see that it floats. It just bobs around for a bit. So it floats at the top of the liquid. And that is because the forces are balanced. So gravity is pulling the apple down, trying to pull it down, but the water is pushing up against it. And that is this thing called uplift or buoyancy. So the apple is floating because it is being pushed up. And this is really, really important when we explore floating and sinking. Next. Now, what I'm going to do is I'm going to ask you all a question and just try and answer it now. If you want to just answer it in your head or you want to shout it out, not too loud. Why do things sink? So have a think, why do things sink? Now, what you might have shouted out or what you might have been thinking is heavy things. If it's heavy, it sinks. So that's great. You're thinking like a scientist. So you're thinking if something's heavy, it sinks. So then I said, brilliant, that's good thinking. However, why do boats not sink? So boats are very, very heavy, but they float on the water. And that's what we're going to try and answer today by exploring a little bit about floating and sinking. Why does a boat not sink? So I'm going to need my objects. So what I've done is I've went around and I've collected some objects from my house. And I've got some things that I need to tell you about. Now, when we're talking about floating and sinking, you can rightly think, well, heavy things sink and light things float. That's brilliant. But I'm just going to use these objects here to talk about this thing called density. So density is really important when we're talking about floating or sinking. So what does it mean? A certain space. So for the older boys and girls, you will be thinking about mass, how much mass takes up how much volume. But for the younger children, you can be thinking how much stuff takes up how much space. So this bit of metal and this bit of wood, they take up the same amount of space. But the metal is heavier than the wood. So we would say the metal object is more dense than the wooden object. And this is a great way of showing. If I get the water, so even those two objects are the same size, the wood one will float and the metal one should sink. Now, so then two objects are the same size, so the metal one has sunk and the wooden one has floated. I'm going to get very wet. Don't worry, you're not all going to get this wet. So that's what you think would happen. So that's what when I asked the first question, a lot of you would have thought or said because something's heavy. Now, these two objects are the same weight. They have the same mass. So they're the same weight. So you would think they'll either both sink or they'll both float. Well, we can have a find out. I'm going to put the first rock into the water and it sinks. And then I'm going to put the second rock in and it floats. But they are the same weight. They have the same mass. And that's because, yes, they weigh the same. However, they are different sizes. So this little rock has a weight, but it's very small. And this rock is the same weight, but it's very big. So this rock has a lower density than this rock. So this is really important. And when we're talking about things floating or sinking, things with a higher density sink. And you can show that because these are solids. These objects are solids. These objects are solids. But even liquids, like the water, also have a density. So you can see that the water is all in the bottom of the bucket. But then gases, like the air we breathe, sits on top. And that's because it's less dense than the water. So as well as solids, liquids and gases all have densities. And it's these things that we're going to explore today. So what I've asked you to get, I asked you to get some random object from your house or from your classroom, and we're going to have a little play and experiment with them. But we're still going to think like scientists. So the first thing I asked you to get is just say some random objects. So I've got some rubber, some metal, got some foam, I've got some metal, a big block of metal, a block of wood, and I've got a couple of rocks. and an apple. So I've got quite a few objects. You don't need this many. So what I'm going to ask you to do is, can you just put, if you've got your little cup or the bucket of water in front of you, just put things you think are going to float on one side and things you think are going to sink on the other side. So you can talk about with your friends or with their parents or grown-ups or teachers or teaching assistants, have a little chat, think why it's going to happen. I'm going to talk you through mine. You don't have to listen to me too much for this bit. We're just going to have a little organised, but remember to think like a scientist, and you need to think about the weight, so how heavy it is, but also the shape. The shape's really important. So I'm going to start organising mine, just as you're organising yours. So I've already tested my wood and my metal, so I'm going to put my metal to the sinking side and my wood on the floating side. And I've already tested these two rocks, so I've got some sinking stuff and some sinking stuff and some floating stuff. Now, metal, so it's a different shape to my metal block, but it's still made of metal and it's still really heavy, so I'm going to put it on my sinking side. The apple, it floated before, so I'm definitely going to put that on the floating side. Now, a rubber bun, this is heavy, but it's not as heavy as the metal, but it is a funny shape. It's a different shape, but I still think it's going to sink. So I'm going to put it there. And the foam block is really light, but it's a square shape, so I think that is going to float. So now, hopefully you've almost finished sorting yours, but you can keep on having a few more seconds. So I've got a section of things that I think are going to sink and a section of things that I think are going to float. Now, remember, that's because of the weight, but also because of the shape. I'm going to put my water there. So now we're going to start testing things. Now, when we talk about floating and sinking, we usually think about water, because this is a type of liquid that's all around us. So we usually think about water. So when you've organised your stuff into things that you think are going to float or sink, as a little scientist, you've really thought is, what is more dense than water and what is less dense than water. So that's what you've thought. That's what your ideas. That's how you've thought like a scientist, and that's what you've decided on. So remember, after we've thought of something, we now need to test it. So we're going to do that together. And just one by one, if you can fit them all in, you can just leave them all in. If you want to take them out after, I'm going to try and leave all mine in. So I'll do the things that I think are going to float first. I'm going to try and hold this up. It's a bit wobbly, this booklet. So the first thing I'm going to do is I'm going to get my rock. So I tested my rock. So you can pick up your first object. It can be a thing that's going to float or sink. And I'm going to put it in. Excellent. So it's sunk to the bottom. Now we're going to move on to the next one. So I'm going to take my bit of metal. This definitely floats, really sunk to the bottom really, really quickly. And then I'm going to take another object. I'm going to take a metal spoon. So I thought this was going to sink as well. And it has. It's sunk and it's just sitting on top of the metal block. And then the last one of my things that I think I'm going to sink is my rubber bum. And I put it in and it's sunk as well. So you can see all of those objects, my objects have sunk to the bottom. Now, if all of your objects have sunk to the bottom, brilliant. That's the ones you were right with your predictions. If it's floating, that's okay. Hopefully, we're going to explain why they are floating. Now, I'm going to use my left hand now. I'm going to test the things that I think are going to float. So I know the wood floated. I just put it on top, and it floats nice on top. I'm going to test my apple, and that one also floated. It sunk a little bit, so it thought about sinking, but then the water uplift pushed it back up. And I've got my rock that floats, and then I've got my foam block that also floats. The foam block sits right on the top. So hopefully what you can see here now is all these objects on the bottom, these have sunk, obviously, and all the ones on the top, these are floating. So what we've worked out here is, with our little experiment, remember we've got the density of water. The objects at the bottom, these are more dense than water. That's why they have sunk. And the objects on the top, these are less dense than water. And that's why they're all sitting floating on the top. So this is about density. Now, just quickly talk about the rock, because the rock is sometimes a bit of a cheat, and lots of boys and girls think, well, why is the rock floated? If I move this rock right next to here, you'll see it's full of lots and lots of tiny holes. But in all those tiny holes, they're full of air. So the air makes it less dense. So that's why it's not solid rock. There's lots of air in there as well, which makes the density, the mass lower. Now, a little tidy up. You can just move your stuff out the way for the time being, and then you could start getting the stuff for your next experiment, which is the 2 little plastic cups of water. I just need this one for the end. So you're going to get your 2 plastic cups of water. So it has to be full to about 3/4 of the way up. You're also going to need just a tiny, tiny bit of washing up liquid and just some paper. That's all you're going to need for this one. Now, it doesn't need to be a big bit of paper. I'll show you how much you're going to need next. I'm tidying up because I need all this. I still need this water. You're finished with your water. Now, what you can think of is when I showed you the pumice stone, this is a kind of a clue, well, one of the clues as to why boats or ships float. Because it's full of lots and lots of pockets of air, lots of little bubbles of air. Now, all I'm going to ask you to do, so if you have got your water, we're going to do this in about just a couple of minutes. We're going to start with this one. So we've got 2 plastic cups of water, about 3/4 full, and we're just going to use a little few bits of paper. You can rip it in half. It only needs to be, I'd say, about that big. And then you just give it a scrumple up, and then you just put it next to 1 cup, and then try and make the paper about the same size as that one, and just stick that next to the other cup. Now, while you're all doing that, I'm going to quickly talk about paper. Doesn't sound very exciting, sorry. But this is really important to how this little experiment works. So paper, if you look at the bit of paper and you pick it up and you have a look, it doesn't look very interesting, but it actually is quite interesting because paper does have lots of air in it. Now, I've just got some kitchen roll here, and you can see this has got lots of little dots. Now, it's got lots of little pockets of air, just like the pumice stone. And what happens is if you put paper into water, this is coloured water, you'll just see, if I get closer, that the water starts to rise up the paper. Can you see how it's rising through? It's travelling through the paper. You just see that. So it's going up the paper. I'm not tipping the paper any further in. The water's actually almost walking through the paper. And that's because of this thing what's called capillary action. And what's happening there is there's lots and lots of little holes in the paper, and the water kind of fills up and moves to the next one and moves up to the next one. So the water can travel through the paper. And that's really important for how this little experiment works. Because what we're going to do is you're going to use some science, and you're going to try and get one of these little bits of paper to sink and one to float. Now, that's a bit wet. Now, for this, all you're going to have to do is you're going to have to put the cup, we're going to put just a tiny little squirt of washing up liquid. It doesn't have to be big, just a tiny little squirt. You give it a little wiggle with your finger if you want. And then we've got 1 cup with water and 1 cup with water with a little bit of washing up liquid. I'm just going to give it a bit of a stir. Now, I'm going to say this scientific term, so the science term, and we're going to explore this more on Thursday's session when we're going to do lots of science with the water, and it's called surface tension. So what happens if I get my water and I put this bit of paper on top? Can you all see it just sits on top? Now it sits on top because 1, it's less dense, so it floats on top of the water. But the reason why it doesn't go too far into the water is because of surface tension. So water, all the little bits that water's made of, lots of hydrogen and oxygen, they all bond together really tight and really like each other and pull back to each other so things can sit on top. You may have even seen like kind of little flies and little creatures sitting on tops of ponds and things like that. That's because of surface tension. Now, what washing up liquid does, reduces the surface tension, so it makes it less. So what we're going to do now is we're going to do a little test, and hopefully you've got your, dry my hands, hopefully you've got your 2 bits of paper, you've got your cup of washing up liquid and water, and you've got your cup of water, and what you're going to do is you're going to just drop the 2 bits of paper in. So we can all do it together in 3, 2, 1, drop them both in, and hopefully you'll see something different will happen. So just look at it there, perfect. So hopefully you'll see this one is still sitting on top, but this one has started to open up and then it started to sink. So hopefully yours is all doing that as well. Don't worry if it hasn't done it as quick as that, yours might take a little bit longer. So what's happened this bit of paper has floated and this little paper has sunk. And that's because of density, but also surface tension. So this paper here, see, it's sitting on top of the water because remember it's less dense. That's because just as the water travels through my kitchen roll, it's full of little pockets of air. So it's less dense. It's almost like it's got little armbands on. But this bit of paper, something different happened. The washing up liquid, remember, reduced that surface tension, so it made it less, so there wasn't as much. So what happened, more of the paper was sitting in the water, so more of the paper went into the water like that. And then the water, like it got into the kitchen roll, started to get in, it started to fill up those little pockets of air with water, so it became more dense, so it was water and paper, and then because that happened, it opened up and it sank down at the bottom. So that was because of density. So that's a lovely little example to show how density works. Now, moving to the side. I don't need that anymore. I've got this here. So this, I'm going to show you a little demonstration or a little science experiment about density. I'm trying to be tidy, but it doesn't really work. So what I've got here is I've got a bottle of oil. So this is just cooking oil, and I'm going to do this as a demonstration, but I'll at the end, straight after, I'll give you a little instructions how you can actually do this at school. So I'm going to take the bottle, top of the oil, and I've got some oil. Now the oil is sitting at the bottom of the bottle, and there's air in this gap here above it. So the air, remember, the gas is less dense than the oil. Now here I've got some water. Now, also what you might not know is even different liquids, so we have water and we have oil, they are both liquids, they also have different densities. I'm going to give this a nice sweep. They also have different densities. So what's going to happen here is I'm going to pour some water into the bottle of oil. Heavy, into the bottle of oil. Now I'm going to tell you the water, this blue water, is more dense than the oil. So the water is more dense than the oil. So what do you think will happen? Do you think the water will float on top, or do you think the water will sink to the bottom? Remember, the water is more dense, and we'll just give you another 5, 4, 3, 2, 1. Hopefully you've all worked out. So now we're going to see what happens. So I'm going to pour the coloured water into the oil. And hopefully you'll see it is, if I stop there, move that. So what should have happened is, can you all see the water has all sunk to the bottom? There's some bubbles, but they're going to sink as well. It's sunk to the bottom, and that's because it's more dense, so it's sunk all the way to the bottom. Now this, I said this experiment is going to be me making what's called a lava lamp. So what we're going to do is, I'm not going to turn the water into real lava, but we're going to get the water to start coming alive and moving around. So I'm just going to put that to the side there. I'm just going to talk about these. Now these tablets are for grown-ups, so again, don't try this one at home. But what I'm going to do is I'm going to show you what happens. So I'm going to get the water to come alive, and I'm going to change the density of the water. Now, if you can just see these little tablets, they've got some chemicals in. They've got some things called acid and an alkaline. Now, when an acid and alkaline react with each other, so when the scientist says react, it means the chemicals start to kind of do something. So these chemicals at the moment, they're not doing anything. They're just sitting next to each other. They're being a little bit boring. They're not having fun. And that's because there's no water in there. They're totally dry. However, what happens when these chemicals get wet is they start kind of like a little bit you at break time. You all come alive and you've all got all this energy and you all kind of have fun. But when these react and do that, they make a gas called carbon dioxide. So the gas you're breathing out is carbon dioxide. So these chemicals in here make that same gas. So what happens when this tablet goes into here, it goes through the oil and then it hits the water at the bottom. When it hits the water at the bottom, it reacts. So it makes the carbon dioxide. Now, the carbon dioxide in there is less dense than the oil. So the carbon dioxide takes the coloured water through the oil, it gets to the top, it leaves the carbon dioxide on the top, and then because the carbon dioxide's on the top and it's just water again, it's more dense, so it sinks. So this is how this one works. Now, if you do this at school and you use a bottle, you never put the lid on the bottle. I'll tell you why at the end. So what we're going to do is I'm just going to get these here. I'm just going to put one in there and another one in there. And hopefully what you'll see is they'll start to come alive. And you can see all the bubbles will start to rise through. You see all the bubbles, all the swirling bubbles, all the little bubbles, and all the big lumps of blue water that are going up. They are full of carbon dioxide. So they are less dense, so they start to float. And then it leaves it on the top up here. And then all the little blue bubbles that are going down, they are more dense. That's because it's just back to being water. So you can see there's lots of big bubbles. Everything going up has carbon dioxide in. Everything coming down is just water. So it's a really, really nice one to do that. And it shows that we can change the density of things and also that liquids have different densities. Now, if you do that at school, you can do it in a bottle or you can just do it in a plastic glass, but you need to leave a gap at the top enough for all the bubbles to go, otherwise it can overflow. And for the grown-ups, it doesn't have to be with an Alka-Seltzer. It can use a vitamin C tablet or even sometimes a little bit of salt will work as well. Anything that would change the density. So, and then when the bubbles slow down, you can put the top on. Now, as I said, you can't put the top on if you do this at school when the bubbles are going super, super fast, because it means the air, the carbon dioxide's got nowhere to go. So the pressure in this bit can build and the bottle can split. But we're going to be playing with that type of science on tomorrow's session. So we're going to be playing around with a little bit of air pressure. So I'm just going to put that there. I need this back. I do it for time, obviously. Now, I'm just going to talk about one more thing before I tell you how ships float and your tasks. So what I've got here is a little tangerine. Now, tangerines are brilliant for telling you why the boat floats. If I put this tangerine in this water, it floats. So it floats on top. So it floats on top because it is less dense. However, if I peel the tangerine, if I take all the skin off, now think about it, if I'm taking the skin off, I am making it less heavy because I'm taking stuff off it. So it's lighter. Just got to make sure you get all the little bits out. This is a great one to show your grown-ups. Your grown-ups don't know this as well. You've got to make sure you get all of the skin off. And then, so I've made it lighter, so light things float. However, this one should, fingers crossed, sink. So it's lighter, but it sinks. And that is because of the skin. So the skin, well, one, it traps a little bit of air inside, so there's some air in there as well. It makes it a little less dense, but also it's the shape of the skin. You can see the bottom of the skin sits like a little cup. And what that happens is, I'm going to talk about surface area again. So the area that's in contact with the water is bigger than when it's just like that. And this is really, really important. And that's brilliant. If you think about a boat or a ship, if I've got the big side, the bottom of the boat here, there's lots and lots of surface area. So there's lots of area in contact with the water, which increases the force. But also, if you think on a ship, there's lots of little rooms. They are full of air. So it's not a solid bit of metal like this one. It's actually a bit of metal like this bit, this, with lots and lots of little pockets of air, which means it's less dense. And then it's got a bigger surface area because of the bottom of the boat, which gives it that thing that's called uplift. So the reason why ships don't sink is because they're full of air as well as metal, and because of the shape of the bottom of the boat. So that leads us on to the task I'm going to give you today. Oh, covered in tangerine. I thought it was water, but it's tangerine. Your task for today. Now, it's a bit more of a kind of experimenting, this task. So what I'm going to ask you to do is, if you can go around and collect lots of things and see if they float or sink. But remember, try and get some things that will float and try and get some things that will sink. Think like a scientist and think, are they heavy, are they light? And take into account the shape. And then I would also like to do you another little challenge. And this is going to be quite hard. It's to just use, well, I've just used a little sheet of paper. I've used one sheet of paper. If you've got a kind of little craft corner or jump modeling, or you've got some sellotape or sticks or anything you can use, the challenge is the stuff that you had that sunk, try and make something float. Now, it does sound really tricky. It is quite hard. I haven't tested this yet because this only works once. But what I've done is I've got my rock. I've got a little bit of paper. I've tried to fold it into a boat shape. And if I put the rock in there, hopefully it will then, fingers crossed, it's now, if you look, the rock is floating in the boat. So that's because it's the same weight, the same mass, but what I've done with the boat is I've increased the surface area, so more area is in touch with the water, so it's getting a bigger uplift. So it's pushing it up. So remember that force of it's pushing it up. I'd love to see you try to not as crafty. If you want to do crazy designs on your boats or anything like else, like rafts, but the challenge is to use your science and think about size and weight and try and make something that sunk float. It's quite a hard one. It's quite a tricky one. You might need a few paper towels with that one, teachers as well. I do have some shout outs before I tell you about tomorrow's session. So we've seen some of their photos there. Miss McGill's class in Year 3 class in St Cuthbert's, absolutely brilliant hovercrafts, some lovely photos, as well as Het and Lyon Primary School Year 6's, absolutely amazing photos. We love seeing them. And also a really big shout out to Jessica. Your hovercraft was absolutely brilliant as well. Also, we've got watching us with Michael Faraday School in Southwark as well, and Whitley Bay Big Local are back watching as well, and the Helmsdale Primary School in the north of Scotland. Hello to everyone up there as well. So again, if you want a shout out, get in touch, we'll give you a shout out. I'm just going to quickly talk about tomorrow's session. So tomorrow's session will be a little bit with forces as well, but we're going to be looking at flight. So we're going to get some things flying around. Sorry, teachers. So what you're going to need for this one is, the first one is, you'll need just an empty plastic bottle. Any plastic bottle will do, has to be empty. It could be a milk bottle like this, has to be a little bit squeezy. Now, I'm going to use, I've lost it, one of my things. If you want to do it out of paper, what you're going to do is you just get a plate like this, draw around a corner, and you just cut this circle bit out, and it's this corner here that you're going to make into a rocket. If you want, even today, on Monday, or you can give it some crazy designs. It was Friday, with the solar system. Do some crazy designs, and then what you're going to do is nice preparation. You just turn it around, and then use a bit of sellotape and stick it into a cone. And it just has to be able to stick on top of your bottle like that. But all you need to try and do is try and get the gap at the top to be as small as possible, so no air escapes, because we're going to be talking about air pressure and flight. And if the other experiment, all you're going to need is a sheet of A4 paper. I think I must have forgot to say something I usually do. So yeah, I'll just say, if you do put any of your after work tasks on Twitter, remember to use the hashtag Science with Neil. Please, if you can put anything on Facebook, tag us in it as well. And if you have any shout out or any task work that you want to send a photo across, please send them across to info@Big Science UK, and I'll get back in touch with that way. I forgot something, but I forgot what it was. Also, if you do like the video, give us a little like, and if you can subscribe to the page, please subscribe, because there's loads more experiments that you can be doing, like fun that you can be doing all week. So this was the last of our floating and sinking. Hopefully you've all had fun. Hopefully you've all, made less of a mess than I have. But I will see you at 2 o'clock tomorrow for having fun with flight. So thank you very much and take care. Bye.